Financial Modeling, Topic 12, Bond Interest and Yield Curve. Section 3, Constructing Yield Curves Using a Theoretical Model. In the last section, we calculated an empirical model. That is, we had a bunch of observed yields on bonds. We plotted kind of a best fit third order polynomial line through it. And we considered that our yield curve to price other bonds. A theoretical model doesn't start with observed yields on bonds. It starts with assumptions about economic variables. For example, the long-term average interest rate, the rate volatility, say the standard deviation of rate changes, and the speed in which rates revert back to their mean. And then we assume some process for short-term interest rates. For example, we might assume that rate changes are normally distributed and follow a random walk process. And then we use that information to develop an entire yield curve. The pros are it's based on economic assumption. The cons, it may not fit very well with today's observed term structures. Some examples of these models are Vasicek and the Cox-Ingersoll-Ross models. So we'll just look at the Vasicek model just to give you an idea for what these models involve. So this model, or what we're going to show as actual formula, is used to derive an entire yield curve based on the evolution of short-term interest rates. It assumes rate changes are normally distributed and follow a random walk process with mean reversion. It assumes a process for the changes in short-term interest rates. The change in short-term interest rate is the change in time times A, which is the speed of mean reversion, times the difference between long-term interest rates and the current spot rate at the time. So what's happening is this process is driving interest rates towards the mean, the long-term average. And then you have this random factor out here, standard deviation times the square root of time times the random z. Now the Vasicek model developed some formulas for pricing bonds and determining yields. I put that formula in based on the textbook, and I implemented it into my spreadsheet. So based on some very simple assumptions, or very few assumptions, I shouldn't say simple, very few assumptions like the current short-term interest rate is 2.5%, the long-term interest rate is 3.5%, the volatility of interest rates is 8%, and the mean the push to long-term rate, the speed of mean reversion, I'll just give it a value of 5. Based on that, I get a theoretical yield curve pricing using the Vasicek formula. I get a 1 through 30 year rate. After I determine the path of short-term interest rate, this is say 1 year interest rates for the next 30 years. Based on that, I can then get a 1 year rate, 2 year rate, and a 30 year rate based on these periodic interest rates, short-term interest rates, and I develop an entire yield curve. So it looks like, based on these assumptions, that current short-term interest rate is going to rise to come up to the long-term average. And if I start changing the assumptions here, I can go from an upward sloping yield curve to maybe a downward sloping yield curve, or a funky hump-shaped yield curve. So this model allows us to develop yield curves.